I am Anil Kumar. This is part 3 of our diagnostic test on calculus. In this part, we will concentrate more on rate of change. We'll take up examples based on average rate of change and then instantaneous rate of change. As you will see, in most of the test papers on diagnostic, there will be many questions on rate of change. Let me share some with you. So here is question number 2, which is based on rate of change. And in this paper, we have question number 2 as well as question number 3 on rate of change. And then in this test paper, question number 3 is on rate of change. And in this test paper, there are very good questions based on rate of change. Now this is introduction to calculus, so even before you begin with, we have diagnostic. You can copy these questions. So that's a very beautiful question. Question number 2, I have taken a similar example to follow. Question number 3, I've actually taken the same example, but we need to find instantaneous rate of change also, which I have not considered, but you can always figure it out, right? So these are very important questions which we should know how to solve. So I'll take up examples which we have discussed on rate of change. Here is question number 12. So we have done first 11 questions in part 1 and 2. Question number 12 is, determine the slope of tangent line to the circle x square minus 2x plus y square plus 4y minus 20 equals to 0 at the point P, 4, 2. Now, how will you do this? You can copy the question, try it out. So we are given equation of a circle which is x square minus 2x plus y square plus 4y minus 20 equals to 0. Now some of our students can directly find center of the circle, right? Some can. But some of my students cannot. So what I will do here is, I'll show you a technique to find center of the circle. We'll do completing the squares method. So in completing the squares method, what we do here is that we add and subtract some constants. You can see x square minus 2x. So let me just copy this. The equation is x square minus 2x. To complete the squares, we can actually add and subtract 1. Now, the first 3 terms you will observe could be written as x minus 1 whole square. You get an idea. So that's completing the square. So half of this 2, square that term and subtract. Now let's look into the other part of it, which is y square plus 4y. Now what is half of 4? It is 2. So add and subtract 2 square. Correct? And then we already have minus 20 equals to 0. Now by doing so, you actually complete the squares. So we have taken first 3 terms, then we have minus 1, correct? Plus y plus 4y plus 2 square could be written as y plus 2 whole square. And then we have minus 2 square, which is minus 4, minus 20 equals to 0. You get an idea. So now we can write down clearly the equation of the circle, which is x minus 1 whole square plus y plus 2 whole square, and these terms taken to the right could be written as 25, which is 5 square. You get an idea. So the center of the circle is at 1 minus 2. So from here, now you know that center of this circle is at 1, 2. Correct? Now we have to find slope of tangent line to the circle at the point 4, 2. So this point is on this circle. What you can do is you can verify just to be sure. So let's do it. So let's verify, just check the point 4, 2, right? Is it on the circle? So for doing so, I'll replace x with 4, y with 2, and see if we get 25. So let me write 4 here. We get 4 minus 1 whole square plus 2 plus 2 whole square, and that gives you what? 4 minus 1 is 3 square plus 4 square, which is 25, correct? That means P is on the circle, right? So there was no need, since it is mentioned, determine slope of tangent line to the circle at the point. That means the point is on the circle. Is it okay? So let's be very clear what we are doing here. So let me sketch a circle here. Let's say this is the circle given to us, and we know that the center of the circle is at 1, 2, 1 and minus 2, I'm sorry. So the center is at 1 and minus 2, and a point 4, 2 is on the circle. So let us say 4, 2 is somewhere here. We need to find equation of the tangent line. So that should be something like this, kind of. Is that okay? So something like this. How do you find that? Well, simple. Now I think you should get it. If I join these 2 points, then we are expecting perpendicular. Is it okay? So this point P and the origin O, we can find the slope of that. So let's find slope of OP. Slope of OP will be, you can use y2 minus y1 over x2 minus x1. So here 2 minus 2 over 4 minus 1. 4 minus 1, which is 4 over 3. So that is the slope of the radius which connects to point P, right? So if this is your tangent line, let's say LT, what is the slope of the tangent line? Now, LT has to be perpendicular, right, at this point. So we say slope of tangent will be negative reciprocal, which is negative 3 over 4. Perfect. Since it is perpendicular, right? So perpendicular line slope should be what? 1 over slope of the line with negative sign, correct? So when you flip it and put a negative sign, you get slope of the tangent line. So this is an extremely important question, especially for my IB students. It's a must to know, okay? Now let's continue with question number 13. Question number 13 here is based on rate of change. The question is, the temperature T in degrees Celsius varies with the distance d in kilometers above the Earth's surface according to the equation T of d equals to 60 over d plus 2. Determine the average rate of change with respect to distance between 3 kilometers and 8 kilometers, right? So average rate of change of temperature, I should have written, rate of change of temperature with respect to distance between 3 kilometers to 8 kilometers, right? So we are given that temperature is a function of distance, which is 60 divided by d plus 2. Now what is average rate of change? Now average rate of change between the two distances, which is 8 and 3, should be difference of temperature at 8 kilometers minus difference of temperature at 3 divided by 8 minus 3, correct? So that's a simple formula. Now in this particular function, we can replace d with 8 and 3 to get the numerator, right? So now we can write this as 60 over 8 plus 2, take away 60 over 3 plus 2, right? divided by 8 minus 3, which is 5. Perfect. Now 60 over 10 minus 60 over 5 divided by 5. Correct? 60 over 10 is 6. So what we get here is 6 minus, and that is 12. 12 over 5. And this is minus 6 over 5. And what are the units? So temperature is in degrees Celsius, and that is in kilometers. So those becomes the units. So degrees Celsius over kilometers. Do you get an idea? So average rate of change is, so we can write down our answer, is minus. That indicates decreasing, correct? Over 5 degrees Celsius over kilometers. Is that clear? So we are done with question number 13 also. Now, as an extension, you can find instantaneous rate of change. So let me write question 13b. Find instantaneous rate of change of temperature with distance, of temperature with respect to distance at d equals to, let us say, 3 kilometers. Okay, so I hope you understand this short form. You should be very familiar with this by now. Now here is the last question of our part 3, and in fact of diagnostic test. The question here is, find slope of tangent line to the graph of the parabola f of x equals to x squared at the point 5, 25. Now let us see how to solve this type of question. In fact, on instantaneous rate of change, which is kind of slope, I've taken 2 questions, one more to go. So we are given the function f of x as equal to x squared. We are given a point P, which is 5, and 5 squared, which is 25, correct? 5 squared is 25. We need to find slope of tangent line to this graph at this point. So we need to find slope. Now, finding slope with just one point, how is it possible, correct? So the problem here is how to find slope with just one point. Well, we can't. The answer is we can't. So the solution is, so we can't, right? So that is sure. So what do we do? So what we do here is we need to take another point which is very close. Do you understand? So since it is very close, we always say estimate. So most of the questions which you will have on tangent, in such cases, the question should have been estimate slope of tangent line. Okay, so that's kind of very important to understand. Okay, so the idea is to understand and move forward. In calculus, all these small things will make a lot of meaning. So let me just sketch this. F of x is, let's say, a parabola x squared. Okay. So what we have done here, think that this is enlarged view of whatever we're talking about. So let me draw a tangent. So what I'll do here is I'll purposely draw a secant kind of a thing. Do you see that? So what I'm trying to say here, that this point for me is 5 square, which is 25. Do you see that? So this point is P. I'm considering another point which is close, let's say Q, and the point here is 5 plus h. H is a small value. Do you see a small value here? Slightly away, and the y value will be 5 plus h whole square. Do you get an idea? Is it okay? So to estimate, we know one point which is 5 and 25. 25 is 5 square. So we'll consider another point Q, which is slightly away, let's say at 5 plus h. And then the y value will be 5 plus h whole square. You get an idea. Why? Because the function is f of x equals to x squared. So now we have 2 points, and since we are interested in slope of a tangent line, we'll say h is very, very small as compared to unit, like 0.0001. You get an idea. That small. Now we have 2 different points, and it's easy to find slope. So we can say slope between P and Q will be what? Will be same formula, y2 minus y1 over x2 minus x1, correct? y2 here is 5 plus h whole square. y1 here is 25 divided by 5 plus h minus 5. Perfect. This minus this divided by that minus this. Now, if you expand 5 plus h whole square, you get 25, which is square of 5, plus 5 times 2 is 10, 10h, plus h square minus 25 over h. Now 25 cancel, so you're left with 10h plus h square over h, correct? You can take h common. Let me take h common. So we are left with 10 plus h over h. Now they cancel out. So we are left with 10 plus h. So approximately this slope is same as 10. So we can say the slope PQ is approximately equal to 10. Since we are saying h is very, very small as compared to 1. Correct? So that is how we are going to get our answer. So find the slope of tangent line to the graph of this. Slope of tangent line is 10. Perfect. So that is how you're going to do it. Now this was one method of doing it. Now in question number 15, I'll show you another method of finding slope. Now we are almost at the end. Here's the last question in this series of diagnostic test for calculus. Question number 15. Find the slope of tangent line to f of x equals to square root x at x equals to 16. Now here I'll adopt third method of finding slope of a tangent line. So we are given the function f of x equals to square root of x. F of 16, that is x equals to 16, should be square root of 16, which is 4, correct? Let's try to understand how to find slope of tangent line. We also call it instantaneous rate of change at a given point. So let me sketch the square root function, which may look like this. Now if I'm talking about a tangent line, let me make one which is not a tangent line but kind of. In reality, we are always talking about 2 points which are very close. So we are given one point is at x16. We'll consider another point which is slightly away, right? Where h is very, very small. Sometimes you can say h is equals to 0.001, right? You could do that. But we'll take general value, correct? So the idea is to understand the concept. Now, slope of this line clearly could be found like this. Is it okay? Rise over run. This is the value at 16 which we found as 4, and this value here will be square root of 16 plus h, right? Since the function is square root x. Does it make sense to you? Right. So from this figure, we can make out that the slope between a point, let's call them as PQ, P to Q will be y2 minus y1 over x2 minus x1. Now y2 is square root of 16 plus h and y1 is square root of 16. And x2 minus x1, which is 16 plus h minus 16. Does make sense to you, correct? Now I could write this as square root of 16 plus h and that is number 4, and denominator is just h. Now how to simplify this? Well, the technique which you have learned is rationalize, right? So we'll rationalize now. You see the importance of rationalization, which we did in part 1. So basically, we will multiply and divide by the conjugate of numerator, which is square root of 16 plus h plus 4 over square root of 16 plus h plus 4, correct? This will give you difference of squares, so we get 16 plus h This will give you difference of squares, so we get 16 plus h minus 4 square, which is also 16, divided by h times square root of 16 plus h plus 4, correct? So you can now, so 16 and 16 cancels, so you get h over h times square root of 16 plus h plus 4, right? Now h and h cancel, so we are left with, let me use a different ink, we're left with 1 over square root of 16 plus h plus 4. Now clearly h is very, very small, so we can consider that to be almost 0. So we get 1 over square approximately. So it is always estimate, correct? Square root of 16 plus 4, which is 1 over 4 plus 4, which is 1 over 8, correct? So that is how you can find slope of a tangent line for any function. Do you get it? So this becomes kind of a general formula or a general method which you can always apply to find slope of a tangent line. So with this, we end our diagnostic, and now in the next part, we'll consider rate of change in further details, right? So we are actually discussing calculus, which is good for IB students, for grade 12 students, and first year university students. And these are the topics which will follow one by one. So I hope you have enjoyed the journey of getting started with calculus, correct? Feel free to share and subscribe to my videos. If you like, that'd be great. Thank you and all the best.